All right, this is Unit 9, Section 9.3. Now we're going to be graphing from vertex form. So last time we were looking at graphing from something called standard form, and so we want to now look at this new form called vertex form. And so when we think about graphing from vertex form, think back to when we did linear equations in integrated 1, and this is where we had y equals mx plus b. So this was called slope-intercept form. It allowed us to identify a point and a slope right away. We also had point-slope form that looked like this. Y minus y1 equals slope x minus x1. And so while this allowed us to identify the y-intercept, this was any point. So slope-intercept form became more powerful as we could move away from the intercept to any point. And then we had standard form, which we could see intercepts pretty quickly. And that looks like this, ax plus by equals c. So we had three different ideas for linear form. Now we're going to look at a second one for graphing vertex form of a quadratic. Notice we still have this x squared going on here. And so 9.3 gives us a different form. It is called vertex form. And what gives it away are these parentheses. And we have A, same A that we've been using. It tells us if it opens up or down, tells us if we have a max or min. But then notice we don't have a B and we don't have a C. So the reason that mathematicians call this vertex form is because it's really quick to identify the vertex. They weren't very creative when they named this one. So when we use A, identify the quadratic, opens up or down. A is positive, opens up. A is negative, opens down. That has not changed. This still gives me a minimum. This still gives me a maximum. But the new part here is identify the vertex. Now we have not x equals opposite of b and plug in. Now we have hk. Notice our h here and our k here. We're going to be able to pull these numbers out, and that's going to immediately give us the vertex. That's why this is called vertex form. It tells us the vertex. But be careful. The h here, okay, is positive. The h inside our form is negative. So what I say is the inside lies. Inside the parentheses lies to us. So we are going to do the same step 3, step 4, and step 5 that we did previously, filling in the table of values and substituting x into the equation. So we're going to still use our calculator and then plot and create our U-shaped, not V-shaped graph. The new part, vertex form, let's practice finding that vertex. So let me start with the first things that we did, just these basic characteristics here. So when I'm looking at this, I'm still going to put an A, just like I did before, out front. And notice that I'm going to do that on these two. I have a negative, so I have a -1. Oh, and I still have a 1 here. So I just had to add 1 to all of these. I have a positive, a negative, and a positive. So this is going to open up, minimum. Opens up, positive, minimum. Negative opens down, maximum. Positive opens up, minimum. The next part we want to find is our axis of symmetry. So x equals, okay, this is going to be the number that's with x, but we have to remember that the inside lies. So when I take something out of the parentheses, -4. So when I take this out, it's going to lie and be +4. When I take +2 out, it's going to lie and tell me -2. +1 comes out as -1. I'm changing the signs. Notice on this one that there's nothing there. I could rewrite this and say this is x minus or plus 0 squared minus 4. There were no parentheses, so if I want to add that, this is what that would look like. But notice that there's nothing in the parentheses. So there's nothing to lie, which means it stays the same. It's still 0, whether it's positive or negative 0. 0 doesn't have a sign. The last part here is finding our vertex. We have the 4, but now we need the y value. That's our h here. Here's our k. We have our h. The outside tells the truth. Positive 2, positive 2. Negative 2 lied. Positive 3 tells the truth. Negative 1 lied. Negative 6 tells the truth. And this is what makes vertex form so much more powerful than standard form, is that we can quickly grab the vertex without doing any calculations. So to me, this is a win. We like to vertex form. We got pretty good at doing opposite of b over 2a. I don't think this is hard, but it's a little bit more tedious. This one, as long as we remember the inside lies, we have h, we have k. We can pull those values out. All right, so let's put this together. Graph each quadratic equation using the table. Identify the indicated characteristics. Okay, so we have a x minus 1 squared, and then I'm going to put plus 0 here so it matches that form of a x minus h squared plus k. So I had to have plus 0 on this one. I have a positive 3, so this is going to tell me it opens up, giving me a minimum. Axis of symmetry, that's coming from h, and it lies to me. So negative 1 becomes positive 1. My vertex, keep that 1 like we have all along, and my k, which is 0. There was nothing on the outside. So just like before, we have our vertex now at 1, 0, and I can use my calculator to find the other points. I'm going to go up 1, up 2, down 1, down 2, and find the other points using my axis of symmetry at 1 to find those other points to plot here. So in my equation, I'm going to go table, clear that guy out, and I'm going to type what I see, 3 times the quantity, x minus 1 squared. Make sure you have those parentheses. And then I can write plus 0 or not. It won't change it. And when I hit enter, I'm going to say, let's start our table at 1, our axis of symmetry, putting that in the middle there. Auto-generate for me. And then 1, 2, 3. Now I'm at 3 and 12 for my other two values. So 3 here, 12 here, 3 here, 12 here. I think this one is one that goes off the graph. So I think our graph only goes up to 8. So we're going to have to plot these where we think they'll land here. But we can get these 3 on the graph. So let's go ahead and do that at 1, 0. Here's our point here. 2, 3, 1, 2, 1, 2, 3. There's my axis of symmetry, getting my 0, 3. And then negative 1 or positive 3, 12. 1, 2, 3, 4, 5, 6, 7, 8. Pretend with me, 9, 10, 11, 12. And we'd have this kind of mirrored side on the other side. So I apologize that that didn't quite fit on our graph. It's a tall, skinny graph here. All right, so this is our first one with quadratic, our first quadratic in vertex form. We're going to have standard form and vertex form. We want to make sure that we recognize the difference, and the parentheses, biggest giveaway. Let's try number 2. All right, so we are given y equals opposite of x plus 2 squared plus 7. All right, so I'm going to put my negative 1 in there as my a to tell me that this is negative 1 opening down, creating a maximum. And then I'm going to have my axis of symmetry. Inside lies coming out as negative 2, liar, liar. It's positive here, negative here. And giving me a vertex of negative 2 from the h, and k here is 7. Most common mistake is either not switching the sign here or trying to switch both. Only the inside of the parentheses lie. So here's my parenthesis or my vertex at negative 2, 7. I'm going to count up 1, 2, down 1, 2, and use my calculator to generate the rest of that table for us. So in my table, I'll clear this one out and put negative x plus 2. Okay, where'd my x go? X plus 2 squared plus 7, making sure that that looks exactly as what I have here. Hit enter. Let's go ahead and start our graph at our vertex. Start our table and go ahead and have it generate that for us. 6, 3 are going to be my other numbers going from -1 and 0. 6 here, 3 here, using my axis of symmetry to match it on the other side. Again, if I want to, I can make sure that this is my true vertex, that I didn't do something or forget. I should check, and going up, I should get 6 and 3. That way I know that I've done that correctly. All right, so then when I'm plotting, I'm going to go -2 and up 7. 1, 2, 3, 4, 5, 6, 7. There's my big point here. And then we have -1, 6. There's my -3, 6. -4 and 0, 3. 1, 2, 3, 4. And draw it in, opening down, just like I said. Have my table. I think these are going to be quicker than what we were doing before. All right, so we have 3 more here. Y equals 1x minus 2 squared plus 4. I'm filling in that a value so I can see it's positive, giving me a minimum. Axis of symmetry of inside lies. -2 comes out, lies to me, +2. My vertex, 2, 4. So I'm going to plug in 2, 4 here, count up, 1, 2, count down, 1, 0, and plug in my calculator. Table, now I'm going to put parentheses, x minus 2 squared plus 4, and go ahead and graph this one, starting at 2, where my axis of symmetry is, and I'm going to get 5, 8 going up here. All right, so should match on the other side, and then I'm ready to plot. Over 2, up 4, 1, 2, 3, 4, and then I should have over 3, up 5, and over 0, up 8, symmetry here. There we go. All right, number 4. Again, these should speed up. I want them to be pretty quick and efficient here, especially using our calculator. So again, I have a negative, so I'm going to tell myself it opens down with a maximum. Inside lies to me. The axis of symmetry is positive here, so negative here as it's lying to me. -3, -6 gives me my vertex. No calculation needed when it's in vertex form. I'll count up, -2, -1, and down. And then I'm ready to go to my calculator. Clear out my table. Let's start fresh with negative parentheses, x plus 3 squared minus 6. Starting now at -3, so I always start at my vertex. And again, you can have it ask you. I just like it to generate it for us. And now we have -2, -1 is -7, -10. And it should match on the other side going away. All right, again, I think these two are going to go off our graph, but we should get a good idea from the other 3 points. -3, -6, 1, 2, 3, 4, 5, 6. And then we're going to go -7 here and here. And this is where we're going to have to pretend. -1, 8, 9, 10. So we kind of have these points that go off our graph. And I'll try to make sure our homework doesn't do that very frequently. That's our second one that did. All right, on the next one. Ooh, okay, so this doesn't have parentheses, so it's kind of a hidden vertex form. So I'm going to rewrite that. I'm going to bring the negative here, and then I'm going to say, you know what? I'm going to put parentheses in there, but I'm not going to change x. X plus 0, still x. But this way I can see my parts a little bit easier. So now I have that -1 here, giving me that opening down graph, giving me a maximum, a high point here, and my axis of symmetry, well, 0 can't lie to us. That's why we can write it either way. It's still 0. And then plus 8 gives me 0, positive 8 on the outside there. Outside doesn't lie to us, just the inside. 0 can't lie because it can't change signs. So now we're at 0, 8 for our vertex. And one more time, go to our calculator. And we're going to enter this in, -x squared. And you can either put the parentheses in like we did here or go back to the original. It will be the exact same. I'm going to start it at 0. That's where my axis of symmetry and vertex are. And I get 1, 2 for 7, 4. All right, 1, 2 this way, -1, -2 this way. 7, 4. Got my axis of symmetry at 0. That's why we center our table there. So at 0, +8, I'm going to go all the way to the top there. 1, here's 7. So -1, here's 7. And -2, +2, they're at 4. 1, 2, 3, 4. And on the other side. And then here's my U-shaped graph kind of going out this direction. All right, I hope that you're seeing that standard form is great, but vertex form is quicker, more efficient. So we'll practice these and kind of seeing how we can move them with standard form and vertex form moving forward. Let me know if you have any questions.